Have you ever wondered how Google works to get you the information you need? When you type in a query, it's like sending a high-speed message to a million servers across the globe. These servers in turn sift through a vast ocean of data, a staggering 22 exabytes per day to be precise. That's the equivalent of over 22 million terabytes. This is all made possible thanks to Google's expansive infrastructure, built and improved over time through numerous acquisitions and partnerships. The mission of Google, as stated by its founders, is to organize the world's information and make it universally accessible and useful. This mission is the driving force behind the Google search engine. It's not just about finding any information, it's about finding the right information, the most relevant and useful results for your query. But how does Google figure out what's relevant? It's not through divine intervention or sheer luck. It's all down to a mathematical algorithm that Google uses to sift through the vast array of information available on the internet. This algorithm, known as PageRank, is the brainchild of one of Google's founders, Larry Page. In the early days of the internet, search engines would rank pages based on how many times a particular word appeared on a page. But Google took a different approach. Instead of just counting word occurrences, Google's algorithm takes into account the number of links between web pages. It's a method that gauges not only the quantity of links to a page, but also the quality of those links. This innovative approach to search brought about a unique mathematical challenge. Imagine the internet as a network of interconnected pages, each passing on its importance to the pages it links to. The result? A web of equations that Google uses to calculate the relevance and importance of every single web page on the internet. In practice, the mathematics behind this process can be incredibly complex, with billions of web pages to factor in. Yet Google's algorithms manage this complexity with remarkable efficiency, delivering relevant search results at lightning speed. So Google's mission is to organize the world's information. But how does it determine what's relevant to your search? That's where the real magic happens, a blend of mathematics and other factors working together to deliver the information you're seeking. In the early days of the internet, search engines had a simple way of ranking pages. They would count how many times a specific keyword appeared on a web page. The more times the keyword appeared, the higher the page would rank in the search results. This was a straightforward method, but it had its flaws. For instance, a web page that mentioned Apple 100 times wouldn't necessarily be the most informative page about apples. This is where Google revolutionized the search engine game. Instead of just counting keyword frequency, Google introduced a new method for ranking pages based on the importance of links. The concept was to consider the internet as a city, where the web pages are buildings and the links are roads. The more roads leading to a building, the more important that building is considered. Similarly, the more links a web page has, the higher its importance. But it wasn't just about the quantity of links. Google also took into account the quality of these links. If an important page links to another page, that second page is considered to be important too. This way, a page with fewer but high-quality links could rank higher than a page with a lot of low-quality links. This method of ranking pages created a more relevant and useful search experience. For example, a web page about apple pie recipes, linked by a popular cooking website, would be deemed more relevant and useful than a page that merely repeated apple pie 100 times. However, this system also posed a unique mathematical problem. If page A links to pages B, C, and D, how do you split the importance of page A among these three pages? And what if page B also links to other pages? The web of links created a complex network of interconnected pages, each with its own level of importance. This innovative system of ranking called for a unique mathematical solution. Google's answer to this was an algorithm known as PageRank, a mathematical formula that calculates the importance of each page based on the quality and quantity of its links. And that's how Google transformed the simple act of searching for information into a sophisticated mathematical process. Enter PageRank, Google's mathematical solution to the problem of ranking web pages. Let's take a moment to delve into this fascinating algorithm that forms the backbone of Google's search engine. Imagine the internet as a simplified universe with just 4 web pages, A, B, C, and D. Each of these pages contains the phrase Bacalhau a Gomes de Sa. Now let's say page A links to pages B, C, and D. In this scenario, each of these linked pages gets 1/3 of page A's importance. Now suppose page B also links to pages C and D. In this case, pages C and D receive half of page B's significance. This process continues for every page and its respective links, creating a complex web of interconnected relevance. What we have now is a system where each page's importance is determined not only by the number of links it has, but also by the significance of the pages linking to it. It's like a popularity contest, with each vote weighted by the voter's own popularity. This is the essence of the PageRank algorithm. PageRank assigns a probability that a random web surfer will land on a particular page. The page with the highest probability of being visited is ranked first in a Google search. It's a mathematical representation of the likelihood of your presence on a web page, given the structure of the internet. But remember, the internet isn't made up of just 4 pages. There are billions of web pages out there, each with its own set of links and corresponding weights. So the math behind ranking these pages becomes a monumental task. Google's algorithms, however, handle this complexity with remarkable efficiency. They sift through the vast interconnected web of the internet, calculate the importance of each page, and deliver search results in a fraction of a second. So the next time you marvel at the speed and accuracy of Google's search results, remember the mathematical genius that is PageRank? It's a testament to the power of mathematics and its ability to solve complex, real-world problems. With billions of web pages to consider, you can imagine the complexity of the math involved. The mathematics behind Google's search algorithm is a monumental task. It's not just a simple equation, it's a complex network of algorithms that needs to analyze and rank billions of web pages. Let's think about it. The internet is vast, with an estimated 1.7 billion websites and counting. Each of these sites can have numerous pages, and each page can have countless links. Now imagine having to analyze all these pages, all these links, and then decide which ones are the most relevant to a user's search query. That's the massive task Google's algorithm tackles every time you type something into the search bar. The math behind this process is called linear algebra, and it's used to solve systems of linear equations. In Google's case, these equations represent the interconnected web of pages on the internet. This system of equations is solved using a technique called iterative calculation, which repeats the same calculations over and over until it arrives at the most accurate result. This iterative process is like a popularity contest. It starts by assigning each page an initial rank. Then it calculates a new rank based on the ranks of all the pages that link to it. This new rank is then used to calculate the next round of ranks, and so on. This process is repeated until the ranks stabilize, and the final ranks are used to determine the order of search results. Now this may sound simple, but remember we're talking about billions of web pages. The sheer size of the internet makes this a gargantuan task. Yet Google's algorithm manages to do this efficiently and effectively, delivering search results in fractions of a second. But it's not all about the math. The algorithm also takes into account other factors such as the relevance of the content to the search query, the freshness of the content, and the user's location and search history. These factors help to refine the search results and make them more personalized and relevant. In conclusion, the mathematics behind Google's algorithm is nothing short of impressive. It's a testament to the power of modern computational mathematics and its ability to make sense of the vast and complex world of the internet. But there's more to Google's search algorithm than just mathematics. Google's search algorithm takes into account many other factors when determining page rankings. While mathematics and link analysis form the backbone of Google's search algorithm, there are also other considerations that influence what pops up on your screen after you hit search. Let's delve into some of these factors. Firstly, the freshness of content is crucial. If you're looking for the latest news on Mars exploration, you certainly don't want articles from a decade ago. Google's algorithm considers the recency of a page's content, giving preference to newer, updated information. This ensures you're not sifting through outdated articles when you're after the latest scoop. Relevance is another key factor. Google's algorithm scrutinizes the content of a web page to understand how well it aligns with your search query. It examines the title, headings, and the body of the text to determine if the content is pertinent to what you're looking for. For instance, if you search for homemade pasta recipes, a page titled "The Ultimate Guide to Homemade Pasta" is more likely to appear in your search results than a general cooking blog. Google also considers the user experience. It prioritizes web pages that are easy to navigate, quick to load, and compatible with both desktop and mobile devices. So, a well-structured, fast-loading website with a mobile-friendly design is more likely to rank higher in search results. Lastly, let's talk about location. Google's algorithm takes into account your geographical location to provide results that are most relevant to you. So, if you're in New York searching for best pizza places, Google will likely show you results from pizzerias in New York City, not Naples, Italy. All these factors and more work hand in hand with Google's mathematical algorithm to deliver the most relevant search results. It's a fascinating blend of mathematics, technology, and user-centric considerations, all working in harmony. The next time you use Google, remember that it's a mix of mathematics and many other factors working together to find you exactly what you're looking for.